This video lecture covers Chapter 6. Chapter 6 makes the switch to talking about production of products. Previously, the previous chapters we discussed consumption of products and how consumers decide how much they are going to buy of specific products. This chapter now we start to talk about how firms decide and businesses decide how much of a product they are going to produce. Several terms. This is a rather long chapter. We have multiple terms we're going to get familiar with here, and they're all listed here, having to do with inputs and outputs and various physical products, different types of costs, different types of revenue. Those things all factor into a firm figuring out how much they're going to produce, and then ultimately the firm seeks to produce the amount of product that is going to maximize their profit. And as we can see, their profit maximization is our final term that we're going to be discovering in this chapter. So this chapter we're only going to look at how a single input, we're going to look at an input of labor, what effect varying amounts of labor has on the different amounts of product that a company can produce. In later chapters, we will talk about multiple types of inputs and the effect that they can have on the amount of product that is produced. Also, we are only looking at products produced within perfect competition. So a product that is produced within perfect competition meets multiple criteria that are bulleted point and listed here below. So products that are produced within perfect competition are homogeneous products made by multiple businesses. Homogeneous meaning the same product made by multiple businesses. Agriculture provides good examples of this because multiple farmers produce yellow number 2 corn. Multiple farmers produce milk, multiple farmers produce beef. So these kind of commodity products are things that sort of fall within the realm of perfect competition. Also within perfect competition is that buyers can choose from many sellers, which is inherent if multiple businesses are creating this product. There's no barrier for entry for anyone interested in producing this product. So if somebody wanted to start up, producing milk, producing corn, nothing's stopping them. And there's a large number of sellers. One seller does not control the product price, so sellers take the price that is on the market, and all producers have access to the same information. So those are all things that fall within perfect competition. It's arguable whether the agriculture industry is perfectly competitive because it doesn't necessarily meet all of these criteria. There is, some barriers to entry like high startup costs and things like that. But overall, agriculture does meet several of these requirements for perfect competition. We need to define business inputs and business outputs. So, because both of these things have to do with production. So, to define an output, that's basically the good that is produced by that business. An input is everything that goes into producing that product. So inputs can be classified as land, labor, capital, and management inputs. Especially with agriculture, if we are growing corn, we have the land and the soil and the water inputs, the labor inputs, all of that's the human work that's associated with planting and harvesting and fertilizing. We have the capital input with the tractors. Capital is manufactured goods such as trucks and fuel that aid in the production, machinery, things like that. And then we have management inputs, which is just the cost of scheduling and organization and marketing the product. So those are all different types of inputs that help to create a product. So how much a company can produce is dependent on the level of inputs that are available to them. So we say that the level of output is a function of the inputs. Input 1 plus input 2 plus input 3. Okay, so for example, the number of bushels of corn that a corn producer can produce is a function, is dependent on all of the inputs: fertilizer, water, labor, seed, etc. So we are going to look at how one input, labor, influences output production in this chapter. In future chapters, we will look at how multiple inputs impact production. So first, when we're considering labor, we have a statement written down here that labor can be measured in either wages, how much it costs per hour to hire somebody. It can be measured in number of hours that people work, or it can be measured in number of total workers. So we don't necessarily define what units we're using in some of these examples, but just keep in mind that's what the numbers could be matched to. So in this chart, we're looking at, we have daily output levels and we have daily labor use. So we can see if our labor use is 10, whether that's 10 workers, 10 hours, $10 worth of labor, we will get 1 unit of output, so 1 product. As we increase our labor here to 16, to 20, to 22, to 26, whether that's hours or people, we will get an increased level of production. That makes sense, right? So we are increasing the hours worked up to 40, up to 50, up to 62, and then we continue to increase how much we're producing. And then we see at some point, we can only increase it so far, and then production actually starts to fall. So we can graph that labor and output data. And when we graph that labor and output data, we can create something called the total physical product curve. So the total physical product curve is just the graph that represents how much product is produced given various labor units. So let's go ahead and take a minute to plot these numbers here. So our labor use is on the bottom and our output is along the side. So when we have 10 units of labor, we have 1 unit of output. When we have 16 units of labor, oops, I want to put the 1 there. 16 units of labor, we have 3 units of output. When we have 20 units of labor, we have 4.8 units of output. When we have 22, we have 6.5. When we have 26, we have 8.1. When we have 32, we have 9.6, 40, 10.8, 50, 11.6, 62, 12, and then 76. We go down a little bit. So our total physical product curve looks like that. So here I'm asking you to circle and label where each of the following is happening on the graph. So where is the total physical product increasing at an increasing rate? Where is the total physical product curve increasing at a decreasing rate? And where is the total physical product curve decreasing? Well, we know the total physical product curve is decreasing here at the end. So that's part C. A and B, this entire time it is increasing, but in order to figure out the rate at which it's increasing, we're going to have to find the slope of the line between each of these points to see when the slope starts to decrease, then we know that it is increasing at a decreasing rate. Okay, so we can't label A and B just yet until we figure out the slope between each of these points, And the slope between each of those points is actually another term, which gives us our marginal physical product. Here's a cleaner graph of the data that we just looked at. So marginal physical product tells us how much more product or output can we produce with one more unit of labor. Or in other words, if we increase input by 1 unit of labor, how much will we increase output? So to calculate this, the marginal physical product is the change in output divided by the change in input. And we find this in between, we can find this in between each point on the graph. So between A and B, the change in output divided by the change in input, so that's basically going to be output 2 minus output 1 divided by input 2 minus input 1. So if we're saying that B is our 2 output and A is our 1 input and output, then we can start to plug in these numbers. So output 2, if B is output 2, so we're outputting 3 units, minus output 1, we're outputting 1 unit, divided by input 2, so our input is 16 units of labor, minus input 1, which is 10. So 3 minus 1 is 2, and then 16 minus 10 is 6. And then if we reduce that down, we're going to get 2/6, which is 1/3, so 0.33. So what that's telling us is that the marginal physical product between A and B, if we increase our input by 1 unit of labor, we will increase our output by 1/3 of a product. Okay, so by increasing our input by 1 unit, we would only increase our output by 1/3. Okay, so then you can calculate those all the way across here, and the answers that we're going to get are from A to B, we're going to have 0.33. And then let's actually go ahead and do one more example from B to C real quick. Okay, so from B to C, if we refer back to our numbers, B, so C, the output is 4.8. So this is 4.8 minus an output of 3.0, because this is 4.8, this is 3.0, divided by input 2, so input 2 is 20, minus input 1, which is 16. So 4.8 minus 3.0 is 1.8, divided by 20 minus 16, which is 4. And then we have to take 1.8 divided by 4. I'm going to do that quick. 1.8 divided by 4 is 0.45. So from B to C, then it's 0.45. Okay, so then you're going to keep on doing that. It might be best if you kind of refer back to the chart that you have with the actual numbers instead of trying to read it off the graph. So what we're going to find is we're going to end up with 0.33, 0.45, and then we're going to also end up with 0.85. Try to get these right. From C to D, D to E is going to be 0.40, E to F is going to be 0.25. F to G is going to be 0.15. G to H is going to be 0.08. H to I is going to be 0.02. Then I to J is going to be negative 0.02. So those numbers, now we can figure out where the total physical product is increasing at an increasing rate. So when these numbers are, when the marginal physical product is increasing, so 0.33 to 0.45 to 0.85, so between A, B, and C, it's increasing at an increasing rate. So that is point A of your graph over here. Now from D to E to F to G to H to I, it's still increasing because it's a positive number and the slope is moving upwards, but it's increasing at a decreasing rate. That means that 1 unit of labor is actually producing less units of output compared to what it was doing before. It's still positive, but it's increasing at a decreasing rate. So our point B is between D, E, F, G, and H. Okay, so that's our point B, and then where total physical product is decreasing is where is I to J, where it actually starts to decrease. Okay, so again, marginal physical product is how much more product can we create with one more additional unit of input, in this case, one more additional unit of labor. So this, you can use this space on your note sheet to calculate those marginal physical products. And we already went over the answers here as well. Now we can take the marginal physical product numbers that we calculated here, and we can plot them to create the marginal physical product curve. We will match each of the labor uses with the second one that it's associated with. So 0.33 was between A and B, so we're going to match it with the labor units for B, which is 16. So 16 we can plot at 0.33. 20 we can plot at 0.45. Why are they jumping? Okay. 22 we can plot at 0.85, and so on and so forth. Okay, so we're going to get a curve here. So eventually we're going up, and then we are going to end up going back down. This is the completed marginal physical product curve. We see that at first it is increasing at an increasing rate. Then it is still increasing because it is still above 0. It's just increasing at a decreasing rate, and then finally it is completely decreasing. So the law of diminishing marginal returns tells us that eventually, if we continue to add more units of input, in this case labor, the amount of physical product that we gain by adding one more unit of input will eventually decrease. So we see that decrease, beginning right here at point D. So, and that, if you think about it, sometimes we have too many people trying to do one task, and then things become inefficient. So there is such thing as having too many workers, because when you have too many workers, maybe people start to get in each other's way and they start to run into each other. Maybe they start socializing and talking. So more labor doesn't always produce more product. Up to a certain point, more labor might be able to produce more product, but then after that, too much, then the production starts to decrease. So that's what the law of diminishing returns tells us. This average physical product we're going to talk about next. Average physical product tells us, on average, how much output are we gaining from each individual unit of input. So this adds up all of the outputs and divides it by all of the inputs. We're not concerned with how much output we are going to gain by increasing by one more unit of output. We're not talking on the margin anymore. So we're not talking about change in output over change in input. Instead, we're taking the total output, dividing it by the total input to figure out on average how much output are we getting by for each unit of input across the board. The average physical product will always increase as long as the marginal physical product is greater than the average physical product. And the average physical product answers this question: what's the average level of output for every 1 unit of labor? So if we wanted to calculate the average physical product, what we're going to do is just take these total output levels and divide it by the total labor, not the change in labor, the total labor. So for this first one, the total output at point A is 1. So total output 1 divided by the total input, which is labor use, is 10. So 1 divided by 10 is 0.1. So for A, our average physical product would be 0.1. Okay, for the second one, we would have, for point B, we would have our daily output level, which is 3, divided by our total input, which is 16. Then we type that into the calculator. 3 divided by 16 is 0.19 approximately, 0.19, and then we have 4.8 divided by 20, and we have 0.24, and so on and so forth. So we'll look at the answers on the next slide. So here, if we calculate all of those out, this is our average physical product numbers, and we can see that they are increasing at first from A through E. They're increasing, and then they start to decrease after that. So at this point is where that marginal physical product also becomes less than the average physical product. So then the average physical product starts to decrease. So again, the average physical product answers the question, what's the average level of output for every 1 unit of labor? Go ahead and plot those numbers for the average physical product curve on your note sheet, and then we'll look at the relationship between the two. So after you have it plotted, it should look like the average physical product curve goes like this, and you have your marginal physical product curve. So 3 conclusions that we can draw from these 2 graphs. If the marginal physical product curve is above, so this section right here, it's above the average physical product curve, then we know that the average physical product curve is rising because each unit of labor that we're adding to that, we're creating more product, so the average physical product is rising. If the marginal physical product curve is below, so in this red portion, the average physical product curve, then we know that the average physical product curve is falling, which it is falling here when the marginal physical product is below. And so therefore we also know the point at which the marginal physical product curve cuts the average physical product curve, where it crosses it, that is the peak, the maximum of the average physical product curve. This helps us to divide production into 3 stages. Okay, so let's actually move on to the next slide quick. Stage 1 of production is found in this first part that we identified. So stage 1 is where the marginal physical product lies above the average physical product curve. So right here is stage 1. Stage 2 of production begins at the end of stage 1 and continues until the marginal physical product becomes 0. So stage 2 starts here and then goes until marginal physical product equals 0. So this is stage 2. And then stage 3 of production begins at the end of stage 2 and is everything that is below 0. So stage 3 is right there. So why this is important is because a firm needs to figure out at what stage of input is going to help to maximize their profit and at what point they should be producing in order to maximize their profit. Well, in stage 1, they are continuing to increase their average physical product, so the amount that they're producing per level of input is increasing, so they obviously want to continue to increase at that point. They want to increase production, so they want to continue to increase inputs, increase labor throughout the entire stage 1. At stage 3, the more labor that they're adding, actually the less that they are producing. So they do not want to continue to produce at stage 2, or at stage 3, sorry. So profit maximization lies somewhere in stage 2, but we don't know exactly where. Profit maximization. We don't know exactly where. We actually need more information to figure out exactly what level of labor use, what level of input will maximize production profits. This slide just summarizes what we just went over. Again, operating in stage 1 and stage 3 does not make sense. So if we're trying to figure out where in stage 2 a firm would maximize their profit, the missing information that we still need is the price of the product that we are producing, what we can sell that for, and the cost of the inputs that we are using. So that's the information that we are missing. So the second half of chapter 6, we're talking a lot about these pieces. Before we start talking about the costs and the prices, let's look at a couple of quiz questions. So one of these quiz questions asks, the stage of production where the total physical product curve begins to decline corresponds to stage 1, stage 2, or stage 3. We didn't put the total physical product curve, we didn't match that up with the stages, but if we look at the total physical product curve here, that was the very first curve that we looked at that just looked at the relationship between labor use and output, just the totals. Now we can see the total physical product starts to decline, meaning when we increase labor from 62 to 76, we actually produce less. So that's happening at this IJ section over here, and we know that stage 3 is the point where we actually are putting in more inputs for less output. So we're spending more money to create less. So that would be stage 3 is what we're looking at. And then here's another question. An example of average physical product in agriculture is the yield or number of bushels of corn produced per acre. Now, even though we talked only about input as a unit of labor during this whole chapter, average physical product and marginal physical product can refer to any types of input. So if you recall from the first couple slides, other types of input included land, capital, land capital, labor, and management. So, so don't let this question trip you up. So an acre is an example of an input, that's land, right? So average physical product is the yield or number of bushels, so that would be your output of corn produced per acre. So yes, that is an example because it is an output over a unit of input, okay? So with that, we are going to pause our chapter 6. So this lecture is just going to cover the first half of chapter 6, and the next lecture video will cover the last half of chapter 6. Okay, so we'll pick up where we left off with the next video.